This is section 10.7. We're going to talk about the equation of a circle. So different equations can graph different things. So if you want to graph a line, you can graph something like y equals mx plus b. If you want to graph something that looks like a u, which is called a quadratic, that would have been y equals ax squared plus bx plus c, where we have an x squared in the problem. So we want to make a circle, we have to have an even more complicated equation. And that's going to be, in parentheses, x minus h squared plus in parentheses y minus k squared equals r squared. And the things we're going to be plugging in are the center, which will be our point h comma k, so they'll go in one with the x and one with the y, and the radius of the circle. Notice it's minus, so what's going to happen is both these terms are going to switch their signs when they go into the equation or when they come out of the equation. So for example 1, we want to write the equation of the circle in standard form. So if my center is negative 2, 9, it's opposite signs. So instead of x minus 2, it's x plus 2 in the parentheses squared. Plus, now it's going to be y minus the 9 squared equals 7 squared, which I'm not going to leave as 7 squared. I'm going to turn that into 49. And that's it. There's no more work to be done. We cannot simplify it any further. This is the equation of that circle in standard form. If you need to show the plugging in first, that's fine. So if I'm going to do that on B, I'm going to show my plugging in. So the origin really means the center is 0, 0. So if we had x minus 0 squared plus y minus 0 squared equals the radius squared. It's okay to write it as this step first, but we still need to show what it is once we've done things like the squaring. Also, x minus 0 is just x. So this is the only case where we will be able to simplify a little bit. Instead of writing x minus 0, we can do x squared plus y minus 0 is y squared equals, and then the square root of 10 squared. If you recall, the symbols essentially cancel each other out, so we're just left with 10. And that would be the equation of that circle in standard form. For choice C, the center is 3, 0, and the diameter is 12, which means the radius is 6. So if I was doing x minus 3 squared plus y minus 0 squared equals 6 squared, the x minus 3 can't be reduced any further, so that'll stay like that. Y minus 0 is y, so that's y squared equals, and 6 squared is 36. Our last example, they're giving us a picture. The center is 4, negative 1. The radius I can find by counting either a horizontal or vertical line. So the radius connects from the edge to the center, so this line right here would be a radius. And this line right here is 1, 2, 3 boxes long. So my R for this problem is 3. So when we do x minus 4 squared plus y minus negative 1 squared equals 3 squared, that would be x minus 4 squared, y plus 1 squared equals 3 squared is 9. So again, if you feel more comfortable plugging in, doing minus the minus, that's fine. If you feel more comfortable just knowing it's automatically going to be the opposite sign inside, that's also fine. So here are 2 problems for you to try. You could pause. Answers are posted on Google Classroom. For example 2, we want to identify the center and radius and also graph the circle. So the opposites are going to be coming out of here. So instead of a positive 4, we would use a negative 4. And instead of a negative 5, I would say a positive 5. So that is my center. 9 is equal to r squared. So if I take the square root of both sides, r is really equal to 3. So this is my center, this is my radius. When I go to graph it, I would graph my center first. So I'm going to put that point at negative 4, 5. And if the radius is supposed to go 3 units in every direction, from the center in every direction, left, right, up, and down, I'm going to count 3 units. And my last step is to connect them using curves. I don't want to draw straight lines because that would be a square. So I'm going to do my best to make it curved. It's okay if it's not perfect. It's okay if it looks weird. As long as we could tell you we're aiming for a circle, we're pretty happy. So that is example 2A. For B, we had nothing being added or subtracted from the x, so that is 0. Y plus 3, we're going to take the opposite. We're going to make it a minus 3, so that's my center. And r squared was equal to 25. So taking that square root, my r would really be 5. To graph this, I'm going to graph my point, 0, negative 3. And now we're going to go 5 spaces away. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The bigger the circle is, the harder it is to do it neatly. Let's see how badly I do here. Okay, that was not terrible. It's not the best, but it was not terrible. So that would be our circle for for example, 2B. So there are two there are 2 here for you to try. One's here, one's here. They're posted on Google Classroom. But that is the end of section 10.7.